Hello, so in this video we're going to look at using sine rule to find lengths in non-right angle triangles. Make sure you're following along. I'd be getting pen and paper and pencils to draw your diagrams as well. You can pause the video at any time to catch up, but I do strongly recommend that you write down these examples and you follow along. You're not just listening to the video, you've got to make sure you're writing things down. It's really important for you to understand what's going on. So we're going to look at sine rule. We're going to be finding the value of x in these questions, and in these questions, x is going to be the length of an unknown side. So let me get my ruler out. Let's draw question 1. So remember, sine rule is used in non-right angle triangles. So get your pencil and ruler out yourselves. Pause the video if you need to catch up, although you probably will be a bit quicker than me, I would hope. But keep your notes nice and neat so you can refer back to them. So there's my triangle. We're going to label these A, B and C. Remember, we tend to use uppercase letters or capital letters for the corners or the vertices of the triangle, and they represent the angles. And then for lengths, we'll use lowercase letters. But here's our triangle ABC. I'm going to give you angle A as 67 degrees. Remember, this is not to scale. I'm going to give you angle B, without moving the screen around, hopefully. Angle B, I'm going to give you as 43 degrees. And then I'm going to give you 4 centimeters on this side. And I'm going to call this is our unknown value x here. So we're trying to find the value of x, and x represents the length of a side of the triangle, in this case the length of the side that connects BC, so the length BC. So first thing to recognise is that it's a non-right angle triangle, so some other techniques such as Pythagoras and SOHCAHTOA or right angle trig, we can't use them here because this is a non-right angle triangle. But that opens up the option of using sine rule, or potentially cosine rule when we come onto that as well, because they can be used in non-right angle triangles. So what highlights that we're going to use sine rule here as well is that if you're ever given an angle and the length of its corresponding side, so in this case we've got the angle B, which is here, we've got the value of that angle, which is 43, and we've got the length of the side opposite that angle here as well, which is 4 centimeters. If you've got those two things working together, then it's the high chance that you're going to be using sine rule in order to solve this question, in order to find x. So the first thing we're going to do is write down sine rule, which is A over sine capital A is B over sine capital B, which is C over sine capital C. Remember, the uppercase letters represent the values of the angles, and the lowercase letters represent the values of the sides. Now in this question, we're not really concerning ourselves with C because we don't have the angle C. There's nothing here to help me here, and there's no value on the opposite side to C. So C is not going to be very useful in this question. So I'm going to be looking at the bit of the formula which has the A's and the B's in, which is this bit, so I can kind of ignore the C over sine bit here for now. So let's have a look at our formula. So we're going to sub into our formula, but first of all we need to label our triangle. So remember, we always label lowercase letters opposite their uppercase angles. So opposite our capital A, which is the value 67, opposite that angle, the length of that side, that's going to be called little a. Opposite our angle B, which in this case is 43, we're going to label the length of the side opposite that, which is the 4 centimeters. We're going to label that little b. And then if we want to, opposite angle C, we don't have angle C, but opposite that, we would be calling that little c there as well. Okay, so we always label our triangle exactly the same fashion, with the lowercase letters opposite the uppercase letters. And once we've done that, like in plenty of problems that we solve, we can now sub into our formula. So we've got A, in which in this case is x. So here's our A, which is x. So in place of A, I can write x over sine of capital A. Remember, capital A represents the value of the angle at A, which is 67. So x over sine 67 is A over sine A equals B. So little b is the value of the length, which is now down here. So b is 4 centimeters. So I can put 4 over sine of the angle B. The angle B is here, which is 43 degrees. So I can sub 43 in here. I don't need this third part of the formula. I don't need C because I've got no information there. And here I've got enough information to solve this now for x. So remember, in this, x is the value of the length. That's the thing we're trying to work out. Here, x is divided by sine 67. Remember, sine 67 is one thing. It's just an ugly number. So we're going to treat it like that. So if we're dividing by sine 67, we can multiply both sides by sine 67. So to get from here to here, I'm going to multiply by sine 67. And because I've already got a fraction on the right, if I'm multiplying by sine 67, that's just going to attach itself to the top of the fraction. And we always write numbers and then we write our function after. So 4 times sine 67, that'll be on the top, and the sine 43 remains on the bottom. And then I can just stick this in my calculator. I can find my value of x, make sure calculator's in degree mode, in the right mode. So 4 sine 67 divided by sine 43 equals, and we get 5.398, etc. So when we round this, so length, we're going to round it to 3SF, so 5.40, and we're in centimeters, and there's our degree of accuracy, 3SF. Okay, so this would be our solution to this. Remember, when we're rounding, the third significant figure is the 9, and the 8 is going to round it out to a 10, so I carry 1 to the 3, so it becomes 4, and I put my 0 down next to it.